What is up, everybody? Today we're gonna solve 9709 22 October November 2017 115 minutes paper, of pure mathematics 2. Right, let's just start. This is my first video. Use logarithms to solve the equation 5 x minus 1 equals raised to 4x, giving your answer correct to 3 significant figures. Alright, so I guess the first thing is gonna be we'll just take the logarithm of both sides. So log 5 raised to 3x minus 1 equals log 2 raised to 4x, and I'm pretty sure you are aware of this rule now. If you have this can be made equal to this. Alright, the power can become a coefficient. So we do the same thing over here. We have 3x minus 1 log 5 equals to 4x log 2. Then just simplify. Log 5 minus log 5 equals 4x log 2 log 2 and four x log 2 minus wait 3x log 5 minus 4x log 2 equal to log 5. Alright guys, then now we just have to simplify even further. 3 log 5 minus 4 log 2 equals log 5. So now we have x equals log 5 over 3 log 5 minus 4 log 2. And if you solve this using your calculator, you will get 0.782 up 3 significant figures. Moving on to the next question. It is given that x satisfies the equation this. Find the possible values of. Alright guys, so only using this part, x plus 1 equals 4 or x plus 1 equals to negative 4. Moving on, x can be equal to 3 or x can be equal to minus 5. I'm pretty sure everyone knows why we have two equations using this one equation, because this value is mod. Alright, now we just have to substitute and find the two possible values of x. So we substitute in x plus 4 minus x minus 4. Alright, so 3 plus 4 minus 3 minus 4, if you solve this you'll get 7 minus 1, which is 6. This the addition for this is minus 1, but since it's minus 1 inside mod, we get positive 1. And then we have minus 5 plus 4 and minus 5 minus 4, which is minus 1 minus 9, which is minus 10. Alright guys, I just noticed this part right here gives you minus 1, which is actually 1. So sorry guys. So this is positive 1, negative 9, we get negative 8. Alright guys, I'm so sorry. Moving on to the next question. The curve of the equation of a curve y equals tan half x plus 3 sine half x. The curve has stationary point m, the interval like this, find the coordinates of m, giving each one correctly 3 significant figures. Yeah, so for a stationary point, for any curve, a stationary point is where the gradient of the curve is 0. And gradient basically means, in terms of calculus, it's dy by dx, which is the derivative. So we take derivative of this, we get dy dx equals so dy dx equals, so first we have to take derivative of tan half x. So yeah, first we should know the derivative of tan x. We know that y equals tan x, and which means y is also equal to sin x upon cos x. Dy by dx will give you cos square x, using the quotient rule, minus, let's see, minus sin square x upon cos square x, which is 1 upon cos square x, which is sec square x. So we just have to use the chain rule to differentiate tan of half x, which is going to be sec square half x, then the derivative of half x, which is going to be half, plus 3 cos half x multiplied by half. Alright, the derivative of the inside term. So this is the derivative of tan half x, and this is the derivative of 3 sine half x. And the gradient is 0, so sec square half x is equal to negative 3 cos half x. Sec square is basically 1 upon cos square, so we have 1 upon cos square half x, which is equal to minus 3 cos half x. If we multiply both sides by cos square x, we get negative 1 by 3 equals cos cube of x. Alright guys, the main thing is y'all have to keep in mind the range, alright, the interval. So we have the first thing is we have to take cube root. So cube root of minus 1 upon 3 is cos half x. So the cos inverse of cube root 1 by 3 is and don't worry guys, you'll be able to do it using your calculator. So it's 2.337. Let's take 2 or 2 values, guys, because the values will be multiplied by 2, remember, because this value is just equivalent to half x. It's 2.57, or to find the other value, we can just use the cos square curve, which is this. So this 2.37 value comes somewhere around here, so the other value is gonna be over here, this value, this one. So this is gonna be equal to 360 minus that. Alright guys, so yeah, so well, this other value is 3.946. Now these two values are equal to half of x. The range given is 5 to 2 pi, which is 180 to 360. So half x equals to 2.337 or 3.946. So x is going to be equal to 4.67 or 7.892. But value of 2 pi is approximately 6.28. This value, however, is more than 2.28, so this won't fit in the condition. So the only possible value for x is 4.67. And then question says each coordinate. You have to find each x and y coordinate. So we found the x coordinate. X is 4.67 only. Y coordinate, you can just substitute in this equation to find out. Yeah, so if you substitute, you will get y equals 1.12. Alright guys, moving on to the next question. The polynomials p of x and q of x are defined by this. So that x plus 3 is a factor. X plus 3 is a factor of p of x and also a q of x. So when x equals minus 3, p of minus 3 is equal to q of minus 3, which is equal to 0, because this value is a factor. It means x equals minus 3 is a root, and when you substitute the value of x for the root, you get the function's value as 0. So now I guess we'll just get two simultaneous equations. Let's start with q first, because there's only one variable to work with in both of them. Alright, we can take any of them. So p of minus 3 is equal to minus 3 cubed plus minus 3 squared, minus 3a minus 15 is equal to 0. So a is, if you just solve, simplify and substitute, you will get a as negative 11. And if you do the same thing for q of x, so q of minus 3 is equal to 2 minus 3 cubed minus 3 squared minus 3 plus 21 equals 0. You'll get b is equal to negative 8. Alright guys, hope you understand this. Moving on to the next question. Show that the equation q of x minus p of x is equal to 0 has only one real root. Yeah, so we'll just do this. Q of x 2x cubed plus x squared minus 8x plus 21 minus p of x. So we'll have x cubed. We'll have x cubed plus 3x and $36. Alright, and this equals to 0 at only one root. Alright guys, so since we know x plus 3 is a factor of both px and q of x, we can just, divide x plus 3 by x cubed plus 3x plus 36. So x plus 3 divided by x cubed plus 3x plus 36. Let me just check. Yeah, so if you divide this, you will get, that's all. So the first term is x squared, so x cubed plus 3x squared minus 3x squared plus 3x minus 3x minus 3x squared minus 9x so 12x plus 36. This is gonna be 12x plus 36, yeah. So, well, this equation is equivalent to this: x plus 3 multiplied by x squared minus 3x plus 12, which is equal to 0. Alright guys, I hope you understand. If let's just revise. So this values, this right here is what we got by subtracting p of x from q of x. Then we know that x plus 3 is a factor of x cubed plus 3x plus 36 because it's a factor of both px and qx. So we just use that factor and we get a remainder 0, and we get this as a quotient. So quotient into the factor, which is x plus 3, should give you this. So this is equivalent to x cubed. So this is equivalent to x cubed plus 3x plus 36. If you solve, you get x equals to minus 3, and for this part we can just use the quadratic formula. So x equals minus 3 plus minus root of b squared minus 4 ac divided by 2. But if you see carefully, this is not a real number. So the other factors of x using this quadratic equation are not real. The only real factor is x equals minus 3. Hope you guys got it. Alright, so just to clear up some doubts, it's just that this root 3 squared minus 4 squared, this part, the discriminant, is actually less than 0. We have this in AS level, minus 4. If it's less than 0, means the equation has no real roots. In this case, the quadratic equation has does satisfy this, means there are no real roots. The only real root is x equals to -3. Now coming to a bit of some calculus. The diagram shows the curve y equals 4a minus 2x and a straight line. The curve crosses the y-axis at the point P. The straight line crosses the y-axis at the point 0, 9, and its gradient is equal to the gradient of the curve at P. Okay, guys. So if you draw a, let me just clear this up. You have y equals 4e raised to minus 2x. If you draw a tangent at this point P, the gradient of this tangent will be equal to the gradient of this line. Alright, guys, so we just have to show that the x coordinate of Q satisfies this equation. As I just said, the gradient of this line at point P is equal to this line, this curve. So the first thing we'll have to do is find the gradient of this point, this line. So we can use dy by dx. Dy by dx is equal to 4e raised to minus 2x multiplied by minus 2. Chain rule, remember, guys. So minus 8e raised to minus 2x. But to be able to find the exact gradient, we need to know the coordinate of this point P. So first you'll find the coordinate of point P. We know that point P is the y-intercept of the curve. So at this point x is 0, so y equals 4e raised to 0, which is 4. So P has a coordinate of 0, 4. So we just need to find the gradient at point P, which is dy by dx at x equals 0 or y equals 4, it's the same thing. So minus 8 e raised to 0, which is going to be equal to, which is equal to minus 8. Then so what we have is, we know that the gradient of this point P is minus 8. The gradient of the curve at point P is minus 8, so the gradient of this line is also minus 8. So we can just use y equals mx plus c. So we know c is the y-intercept, and the gradient, which is m, we just found it minus 8, and y-intercept is 9 for the line. So we just substitute in, we get y equals minus 8x plus 9. Then what we want to do is, we want to find the coordinates of Q. Q is actually the point where the curve and the line meet, so the point of intersection, which is found out by equating the values of y, because at this point they have the same y and x values, correct? Both the line and the curve have the same y and x values, so we can just equate them. We have 4e minus 2x which is equal to this equation of the line, which is minus 8x plus 9. We want to find the x coordinate, so this is the equation. All you can do is just no, wait. 4e raised to minus 2x minus 9 equals minus 8. Multiply both sides of negative 1, we get 9 minus 4 raised to minus 2x equals 8. Then if you divide, oh sorry, this is 8x, so sorry. If you divide both sides by 8, we get 9 upon 8 minus 4 upon 8 e raised to minus 2x equal to x. This will give you half. So we finally get this. Alright guys, moving on to the next question. Use an iterative formula. Okay. So the equation was x equals 9 upon 8. So sorry. 9 upon 8 minus half e raised to minus 2x. Then we can just convert it into an iterative formula. Then we know that q is gonna be positive. So let's start iterating with the value x1 equals to 1. So now x2 is gonna be, for those who don't know, we'll just substitute this value in this equation for xn. So x1 is gonna be xn now for x2. Alright, so in this we are going to use xn as x1. So well, we get 1.05733. Remember guys, give each iteration to 5 significant figures, but the final answer should be 3 significant figures. Alright, so x3 now is gonna be, now we'll use this value for x3. We get 1.06466, x4 1.06554. Now if you see we only want 3 significant figures, let's do one more iteration. We get 1.06565. so if you see only 3 significant figures, we get 1.07. we need to round off 65 to 1.07, so x is equal to 1.07. Alright guys, now let's complete some integration again. Find the exact value of this. So 4 sine square x plus 6 cos x sine x and now let's see how can we convert it to a form which we can integrate. Well, we know the integration of cos 2x, sin 2x, sin 3x, cos 4x, but we do not know the integration of sin square x. So we need to somehow simplify this. Okay, great. Let's just talk about this term first. We know 6 cos x sin x can be converted to 3 times 2 cos x sin x. And if you check the data booklet, it's mentioned that 2 sin x cos x is equal to sin 2x. So this is equal to 3 sin 2x. Alright, so the second term is now it's now simplified to 3 sin 2x, which is just which can be just simply integrated. now comes for sine square x. Alright, so well, we know we can convert this to, let's say, 4 into 1 minus cos square x, which can be converted further down to 4 minus 4 cos square x, which is equivalent to negative 4 cos square x minus 4. Oh, by the way, if you guys still didn't get it, I'm just trying to convert it into this format, the one in the data booklet for cos 2x. Alright, so we have negative 4 cos square x minus 2, then we can just take this part, minus 2 cos square x minus 1. Alright guys, then we have minus 2 over here, which is equal to 2 minus 2 cos 2x if you simplify and open up the brackets. So now we just got these two terms, the first and second term, and now we can just simply integrate it. So you have 2 minus 2 cos 2x plus 3 sine 2x, integration with respect to dx from 0 to pi by 4. 0 to pi by 4. Alright guys, now it's just simple integration. We have 2x minus 2 sine 2x upon 2 plus if you check the data booklet, the integration of sine 2x, sine x is, well, negative cos x. So this would be negative 3 cos 2x upon 2. Yep, and this will be integrated from pi by 4 to 0, which is 2 pi by 4 minus sine 2 pi by 4 minus 3 upon 2 cos 2 pi by 4 minus 0 minus 0 and minus 3 upon 2. Alright guys, so we have pi upon 2 minus 1 minus 0 plus 3 by 2. Alright guys, so we just have to find the exact value, which is going to be pi upon 2, and 1.5 minus 1 is 1, plus 1 by 2. Alright guys, moving on to the next question. Yeah, it is given that so since it's in this form, we just have to use natural logarithms. The integral is gonna be 6 ln 3x plus 2 divided by 2, 0 to a, which is equal to ln 49. 3 ln 3x plus 2 is equal to ln 49. So 3 ln 3a plus 2 minus 3 ln 2 is equal to ln 49. Yeah, well, we have 3 ln 3a plus 2 is equal to ln 49 plus ln 2 cube, logarithms, which is equal to ln 49 plus ln 8, then 3a plus 2. Sorry. Yeah, we can just simplify this further. Ln 49 times 8, which is ln 392. So 3 ln 3a plus 2 is equal to ln 392. Ln 3a plus 2 the whole cube, power laws of logarithms equal ln 392. And oh, so sorry, my bad. I just realized this value needs to come here, so this is gonna be 3. So this changes everything. 2 squared. So now instead of 2 squared we have 2, instead of 2 cubed we have 2 squared, which is 4, and 49 into 4 is 196. Yeah, so wait, I just realized this is gonna be 3. So this over here is gonna be 2. 6 divided by 3. So we have 2 ln 3a plus 2, which is equal to ln 49 plus ln 4, using properties of logarithms. 49 into 4, which is ln 196. So we have ln 3a plus 2 the whole square, again using properties of logarithms, is equal to ln 196. So if you raise both sides to e, the e and ln get cancelled, so 3a plus 2 equals square root 196. 3a plus 2 equals 14. A equals 4. Alright guys, let's move on to the next question. The equation of a curve is this. Find the equation of the tangent of the curve at point -1, 3. Give your answer in the form ax plus by plus c, where a, b, and c are integers. Alright, so well, we need to find the equation of the tangent of the curve at point this. So for tangent we need to find the gradient, which is basically dy by dx. So in this case, since x and y are all combined, we can take derivative of both sides. So derivative of x squared plus 4xy plus 2y squared equals derivative of this is gonna be equal to 0 anyways, because derivative of any number is always 0. This part we'll have to divide it into x squared, 4xy, and 2y squared. Where for 4xy we are going to use product rule with chain rule. So first, let's take the derivative of 4xy, which is the product rule now. Derivative of 4x multiplied by y plus 4x multiplied by derivative of y with respect to x. Remember guys, we are taking the derivative of both sides with respect to dx. Well, with respect to x. So for the first part it's just 4y. Second part is gonna be 4x dy dx. Remember guys, we are doing we get dy dx because if you see the chain rule application, this we can simplify this as derivative of y with respect to dy multiplied by dy by dx. We know derivative of let's say we have derivative of x, so this is always going to be 1. So we'll use the same thing here. Derivative of y with respect to y is going to be 1 multiplied by dy dx, so which is dy dx. Now coming to 2y square, we'll use chain rule. Derivative of 2y squared with respect to y multiplied by dy by dx, which gives us 4y dy dx. Now we just get the whole thing. We have the derivative of x squared is 2x. Come on, that's simple. So dy by dx is equal to 2x plus 4y dy dx plus 4y plus 4x dy dx plus 4y plus 4x dy dx, which is equal to 0. Now guys, this is the derivative equation for the graph. This is not dy by dx, this is the derivative equation of the graph, and we just have to substitute these coordinates as x and y. So after we substitute, we get, so x equals -1 and y equals 3. So we'll just substitute these and we'll get -2 plus 12 dy dx plus 12 minus 4 dy dx equals 0. If you simplify, you'll get dy by dx is equal to -1. So now we have the gradient, we have the coordinates. We simply have to find the equation of the line. So we can use these x and y values. Y minus y1 equals m x minus x1. So y minus 3 equals minus x minus y minus y. So y plus x minus 2 is equal to 0. Sorry guys, I noticed a mistake here. This is gonna be 4. So yeah, well, substituting, x equals -1 and y equals 3 into this equation, we get -2 plus 12 dy dx plus 12 minus 4 dy dx equals 0. So the gradient, which is dy by dx comes out to be minus 5 by 4. And if you just substitute in this equation, y minus y1 equal mx minus x1. Using this, we get y minus y1 equals mx minus x1. 4y minus 12 equals minus 5x minus 5. So 4y plus 5x minus 7 equals 0. Alright guys, yeah, we converted this equation. Alright, so show that there is no point on the curve that its gradient is half. So we just we have this equation, right? Minus 2 plus dy by dx equals 0. Well, so dy by dx is equal to 12, just to, check if this equation is satisfied. We have minus 2 plus 12 dy by dx plus 12 no, sorry, we're going to use this equation. We don't know the value of y and x, so 2x plus 4y half plus 4y plus 4x half. This is gonna be equal to 0. Now, well, if you just simplify, you get 2x plus 2y plus 4y plus 2x equals 0. So 4x plus 6y is equal to 0. Then yeah, so what we can do is we can substitute we can solve this equation and this equation of the curve simultaneously. So let's say we solve for x, so x equals negative 6y upon 4, which if we substitute in this, we get negative 6y upon 4 the whole square plus 4 negative 6y upon 4y plus 2y squared equals 7. So if you simplify, you'll get negative 7 by 4y squared is equal to 7, and then y squared is equal to negative 4. Do you think this is possible? So we get y squared equals negative 4. Y is negative root 4. This is not possible. Thus, now we have ended the paper. This is not possible. Thus, there is no point on the curve that is gradient is off. Alright guys, hope you like this video. Thanks for watching.